Our first lesson will be an introduction to the practice of statistics. So in this lesson, we're just going to try to understand what we mean when we say statistics, and we'll learn some terminology about statistics that we will use in the future of our course. So we have some objectives for this lesson, and these are objectives that by the time you finish the lesson, you should be able to complete. The lesson will be broken up probably into a couple of videos, so you don't have to understand these things at the start, but at the end of the lesson, you should come back and read these things and make sure that you can do these things, and if not, go back and rewatch the corresponding part of the video. So our objectives will be to define statistics and statistical thinking, to explain the process of statistics, to distinguish between qualitative and quantitative variables, to distinguish between discrete and continuous variables, to determine the level of measurement of a variable. Statistics is the science of collecting, organizing, presenting, and interpreting information to draw conclusions or answer questions. In addition, statistics is about providing a measure of confidence in any conclusion that we may draw. So we are basically asking questions. We want to answer these questions by providing data to back up our answers, and then we want to measure how confident we can be that we have the right answer. A measurement is a number or attribute computed for each member of a population or of a sample. The measurements of sample elements are collectively called the sample data. So in a minute, I'm going to explain to you the difference between a population and a sample, but the key idea is we need to take measurements in order to back up our statements about a question that we have. So here's an example of researcher who had a question. The researchers wanted to know, does Friday the 13th change human behavior? So they formulated a hypothesis. They said if there were fewer vehicles on the road on Friday the 13th than on the previous Friday, this would be evidence that some people were playing it safe on Friday the 13th and staying off the roads. So the first phase of their statistical study is that they needed to collect data. So these researchers obtained the data kept by the British Department of Transport on the traffic flow through certain junctions of the M25 motorway, which is a road in England. The next thing they had to do is to organize and analyze the data. They compared the number of vehicles passing through certain junctions on the M25 motorway on Friday the 13th, and they compared that with the number of cars passing through the junction the previous Friday, and they did this with data from 1990, 1991, and 1992. So eventually their goal is going to be the presentation of the data. The presentation is important, and in this case, the researchers were able to find a respectable journal in which to publish their findings. They published them in the British Medical Journal, but other avenues for presenting data might be giving a talk at a conference, or simply writing a report for your boss, or presenting a class project. And the key feature will be the interpretation of the data. So we collected the data, we analyzed the data, then we have to interpret the data. It's crucial for those who are performing a statistical study to make their results understandable to non-statisticians. It is not sufficient for the statistician alone to understand the results. Rather, the statistician should communicate the results clearly, whether in writing or orally. So in the case of our Friday the 13th study, the researchers chose to compare the decrease in the number of vehicles as a criterion on which to base support for the hypothesis that people are changing their behavior because it's Friday the 13th. They did find an observable decrease in traffic, and that was consistent with their hypothesis. Okay, so that's that example. So let's talk about what a population is versus what a sample is. A population is any specific collection of objects of interest. So we're interested in studying a collection of objects. The entire collection is called the population. Whereas if we take any sub-collection of those objects, we would call it a sample. So a sample is any subset or sub-collection of the whole collection, the population. And we can even include the population itself as a sample. So if you are studying the entire population, then your sample is the population itself, and that study will be called a census if you're studying the entire population. All right. So what we'll be doing in this course are called descriptive statistics, and we call them the building blocks of data analysis. A statistic, the word statistic, is a numerical summary of a sample. Descriptive statistics consist of organizing and summarizing data. Descriptive statistics described through numerical summaries, tables, and graphs. Okay, a few more terminology that we're going to want to know are elements, variables, and observations, and be able to distinguish between the three. So an element is a specific entity about which information is collected. So we know that we're looking at a population or a sample. Any one specific object in that population or sample is called an element. A variable is going to be a characteristic of that element, and it can assume different values for different elements. An observation is the set of values of the variables for a given element. So for a given element, you will have multiple values based on multiple characteristics that you're studying, and all of those values together are the observation for that element. Let's look at an example. So the table here shows information about 5 hospitals. And you can see it's broken into columns, and the title of each column is at the top. We have the hospital name, the type of hospital, the number of floors, the HMO ranking, the number of patients per nurse, and the year opened. Then going down the leftmost column, for each hospital, here's the name. And the rows will correspond to the named hospital. So for the hospital that is named City Hospital, we have its type, its number of floors, its HMO ranking, the number of patients per nurse, and the year open. So that's how we read the table. So we'll be answering a couple questions here. The first question asks us, what are the elements? List the variables. List the values that the variable type takes. So it tells us there that type is going to be one of our variables, and we want to list the values that it takes. Then provide the observation for Children's Hospital. So elements, variables, and observation are the 3 vocabulary words that we have. So the elements, in this case, are going to be City, Memorial, Children's, Elder Care, and County. So these are the different hospitals about which we are collecting data. We're going to call those the elements. Then it asks us to list the variables. So let's do that. The variables should be the type, the number of floors, the ranking, the nurse to patient ratio, and the year that the hospital was open. So this is all of the information for each element, for each hospital. We want to find out what type of hospital is it, what number of floors does it have, what is its HMO ranking, its nurse to patient ratio, and its year open. So I'm just taking these from here. These are our variables. Okay. And the question did give us a hint that type was going to be one of our variables, which we did find that out. So it says for type, list the values that the variable takes. So we're going to look at this column, type. The possible values, it looks like, are either general hospital or specialized hospital. So for type, general or specialized. And then lastly, it says to provide an observation for Children's Hospital. So let's look at all of the information we know about the Children's Hospital and see if we can come up with an observation. Well, first of all, I see the Children's Hospital is a specialized hospital. It looks like it was opened in the year 2005. It's a 3-story tall building. It has 3 floors. Its HMO ranking is number 1, and it has 5.9 patients per nurse. So that will be our observation. Children's Hospital is a specialized hospital that was opened in 2005. It has 3 floors. And its HMO ranking is 1. For each patient, or rather for each nurse, there are 5.9 patients. And I believe we've answered the question. Okay. So a couple more definitions here. I want to talk about qualitative data versus quantitative data. And there's a little hint there in the name. Qualitative data are measurements for which there is no natural numerical scale, but consists of attributes, labels, or other non-numerical characteristics. So I like to think of qualitative data as the qualities of the element. A quantitative variable is a variable that takes numeric values and upon which arithmetical operations such as addition or subtraction may be meaningfully performed. So we would want to think of the quantitative variable as the quantities for the element. So quantitative is numerical. Qualitative is sometimes called categorical. So we have a question. Referring to the same table about the hospitals, let's list the quantitative variables. And then we'll list the qualitative variables. So we might have to go back and take a look. So remember, quantitative is going to be anything that will involve numbers. So it looks like number of floors, I think, should be quantitative. The ranking, the number of patients per nurse, and the year that's open. The only qualitative variable that I see is the type. So qualitative, we said just the type of hospital, either generalized hospital or specialized hospital. The quantitative variables were the number of floors, the HMO ranking, the year that the hospital opened, and the number of patients per nurse, or I think I said nurse to patient ratio. Number of patients per nurse. Next, we'll talk about discrete variables versus continuous variables. A discrete variable is a quantitative variable, so it's a numerical variable that has either a finite number of possible values or a countable number of possible values. The term countable means that the values result from counting, such as 0, 1, 2, 3, and so on. We can't necessarily say that there's a finite number because we could keep counting to infinity, but it is countable. A discrete variable cannot take on every possible value between two possible values. Cannot. So a continuous variable is the other one. It's numerical, but there are an infinite number of possible values, and we can't count them. A continuous variable may take on every possible value between any two values. So we'll make some sense of that in just a second. So it says which variables are discrete and which variables are continuous. So again, we'll need to go back to our chart. We want to look at discrete, continuous. And as we said, these are both quantitative variables, so we don't need to look at type anymore because type was qualitative. So we're just going to look at the number of floors, the HMO ranking, the year open, and the number of patients per nurse. And we want to see which ones are continuous and which ones are discrete. We said a discrete variable will either have a finite number of responses or a countable number. Countable numbers are like 0, 1, 2, 3. So if we look at number of floors, this should be discrete. Because a building will either have 1 floor, 2 floors, 3 floors, or some other nice whole number that we can count. Similarly, HMO ranking looks like it should be discrete because you can be first place, second place, third place, and so on. And the year opened will also be discrete. So the only one that is continuous is this number of patients per nurse. And what makes it continuous? Well, it can take all of the numbers in between the whole numbers. So it can be 5.9, or it can be 12.7, and so on. Or it could be 5.99, or 7.87, or infinitely many other numbers that we can't count. So many of them that we can't count. So if you look at the difference between the continuous variable and the discrete, you'll see that all of the discrete variables take nice whole numbers for their values, and the continuous variable can take decimal numbers, fractions, and all sorts of other numbers. So way more numbers. So let's go back and answer our question. Discrete variables, we said number of floors, HMO ranking, and the year opened. And for continuous, we just had number of patients per nurse. Okay, then we have levels of measurement may be classified according to 4 levels. So we have collected some data, and it can either be nominal data, ordinal data, interval data, or ratio data. So let's talk about what those words mean. Nominal data consists of names, labels, categories. So there's no natural or obvious ordering of nominal data, such as highest, lowest, and you can't perform any arithmetic, addition, subtraction, division, that type of thing. So a lot of times this is going to be our categorical data. Ordinal data can be arranged. So things like high, low, medium, those can be arranged, but no arithmetic can be performed. So we still can't add and subtract. Interval data is similar to ordinal data because it can be arranged, but you have the extra property that subtraction can be carried out. However, there's no natural zero for interval data. Ratio data, similarly to interval data, can be arranged in a particular order. You can carry out subtraction, but now we have the extra property that you can carry out division, and you have a natural zero. So you can sort of think of these as layers. Ratio data is the most flexible. You can order it, you can subtract, you can divide. Interval data, you can order it and subtract, but not divide. Ordinal data, you can order it, but no subtraction, no division. And nominal data, you can't do any of those things with it. So we'll look at another example, but we'll save that for the next video.